Really long final exam. Each week they've been given exercises that were meant to make them reflect on all of the quarters that they've undergone through this entire experience. And they're here to demonstrate that work and show you what they've done. I'm very proud of it. I get to be part of this experience from quarter one. I had many of these guys as students in quarter one. When they came in, they were game players. They were very big about all the awesome things that they could do in the game playing environment. And by quarter 8, they're very much game makers. And this now quarter 12, you get to see that they have completed the entire scope of making a game. It's very impressive. Take it away.
Marty, you can sit up here. There's a seat for you.
Yes.
Sorry, here now.
All right, so our team made the game Polarity Shift. I'm Ken Lambert. I was one of the programmers and the project lead on this. Our team is consisted of Ryan Bedard, Tyler Caffell, Aaron Slosser. Our audio was by Ryan Campos and art by Jessica Shu. They were both external who volunteered to help us out. So the 3 tracks you'll hear in jumping was done by Ryan, and while background art, specifically pictures, was done by Jessica Shu. So the concept of the game basically was to use magnetism as the main gameplay mechanic. So the world we came up with was a place where speed and efficiency are valued above all else, and you play as a robot who is testing magnetism technology in order to traverse quickly and efficiently through the world. So you're in a testing lab testing this technology. So the tools we use to create this are C#, which is the programming language we use, XNA, which is the foundation on top of that, which helps us create the game, and Beppu Physics, which essentially handles all the gravity, collision detection, things of that nature, which just sped up the process for us for making the game. The mechanics you'll see is the player will have the ability to use positive and negative polarity as they traverse through the game, as well as traditional platforming mechanics as you'd see if, traditional Mario game running left to right and jumping, as well as sprinting. Environmental tools that the player will be interacting with will be magnetic boxes, both dynamic and static. So you'll have ones that you'll be able to move and interact with, while ones will be stationary and will move you. Then the environmental hazards that the player will have to avoid, some will be stationary and some will be moving that you have to account for, as well as locked doors that you'll need to find a key in order to exit the level.
All right, well, making this game, we had many different challenges. The first one was listening. Since we had to create the game from scratch, we had to come up with the game idea itself. And at the very start, we were sort of just shooting things back and forth, but we weren't really listening. And then pretty much about by week 3, we sort of got on track, started to listen to each other, and made a lot of progress in the game right there. The next challenge was the game mechanic itself. It's a magnetic mechanic, and the biggest challenge was making it feel like it works the way it's supposed to. So if you turn on positive, the negative block comes towards you. If you turn on negative, the negative block goes away from you. The next challenge was creating the levels themselves. We had to place the blocks in 3D space. I don't know how many here know about programming, but it's very, very tedious to do. Although we did create a tool later on, which I'm going to go over in another slide. The next challenge was art. We are 4 programmers, none of us are artists, so making the art for the game was pretty difficult. We tried having external people create models. We got a concept, but we didn't actually get a robot in. And the last one was Perforce. And what Perforce is, it's a file sharing database, so we'd be able to work on our game from different locations. So Ken could be working on it at home, Tyler could be at school, and Aaron could be at work, and we'd all be able to be working on the game. Now, golden nuggets, what these are things that helped make our game making process a lot easier. The first one was Beppu Physics. physics in programming is very, very tedious to make. But this engine that we used, it handled gravity, friction, momentum, all those variables for us. So it saved us weeks of programming that we just didn't have to do because the engine handled it. And then the next one was the level editor. Aaron took a 2D level editor that we had learned about in a previous class, and he sort of adapted it for our game. So instead of simply placing objects in 2D space, it would place them in a 3D space. Now, for testing, part of our course requirement was we had to have at least 20 people test our game. I took the role pretty much of the lead tester, and my mom, she works as a school teacher at St. John the Evangelist School, so I talked to her and organized a giant testing group with the 5th through 8th graders. So we went to the school on a Friday, and we had the 5th through 8th grade come test our game, tell us what they thought about it. They filled out a survey, and by doing this, we had 101 responses that were just extremely helpful to how we thought our game was going. Yep. Yep. All right, I'm going to get off the Tyler now.
I forgot the lesson. All right. Well, some of the lessons we learned through making this project in 20 weeks, there are a couple big ones that we had to learn throughout. The first was communication. We learned in the very beginning that the internet doesn't show emotion very well. So you say something in a nice way, but you might sound like a jerk, or you might say it wrong, and then everyone gets upset and it causes a fight. So we learned at the very beginning that you had to be gentle and word things very carefully. Another thing that we figured out in the beginning, and this was also part of my fault, was you had to set a conflicts as they arise. As my teammates know, I get a little antsy when things start not going right. So we learned that when there was a conflict between either me or Ken or Aaron and Ryan, that to settle it right then and there, instead of letting it build up and then it explodes after week 10 and nothing gets done. Another great thing we learned, and that was thanks to Ken, was relaxation. On Wednesday nights, we would play a game called Minecraft. I don't know if any of you heard that, but it's basically Legos in the video game world. And we'd all get together on Wednesday nights and play for 4 or 5 hours, and we'd get to know each other and get to hash out ideas, and it all ended up being a big team building experience and helped us create the success in order to create our game. So now, Ryan's going to play test our game for us, and I'm going to walk you through the next couple of levels, of the first couple levels, and show you the development process and the things we did as we went on. So just give Ryan a second, we'll start that right up. We really wanted you to hear the music.
Sorry, the Bluetooth agent cut it.
All right, so first thing you're going to notice is, use that down just a little bit. Alright, so the first thing we're going to show you is our main menu. We have a cool retro video from back in maybe the old school, maybe some of you people from the early 90s played video games. There always be like a demo in the main menu to get you excited. So that was the first thing we did. We wanted to make a little video as a teaser. So Ryan's going to start with the first level. And the first thing you'll notice is the player's tone, the direction. One of our biggest things with building the game was we were told, where do I go? Because in today's modern world with 3D graphics, you have maps and you can see things in the distance. So going back to the 2D, you really couldn't see it. So one of the things we had to do was to show the exit and then a scroll to where the player is, so where to start. Another thing that we had to put in was tutorials, because we're marketing our game towards a younger audience, a younger and maybe possibly older audience. So I make sure to have a good tutorial system in place, and we worked very hard to make sure that the tutorials were easy to understand. And one of the things with Ryan's testing was that when we went to the school, we were able to see how they fed the tutorial, what they liked, what they didn't like, and how we could change it. So as you can see, one of the things we do with our games, we play with the Xbox 360 controller. I'm sure many of you have kids at home who play with an Xbox 360. So we made adapt to that so it's easy to play at home. So the first thing is that you're told to move the left thumbstick to move left to right and continue. So when you first start, you have a lot of information at the beginning. You have your player model in the middle, where Ryan can move. You have the top your time, and our game is based on time high score. So the lowest time is the new high score. And you also see the previous high score if one exists. For this case, since it's Ryan's first run through, it's not available. So as Ryan progresses, he'll be told about more tutorials to help him play our game as it goes forward. So I'm going to let Ryan continue a little bit before I jump back in. Another thing we had was we really didn't want to have like a Mario or Sonic style 3 lives game over. We want the player to keep going to play. So we intentionally put traps in, things where the players couldn't get out, so they have to reset. Like Ryan here, now he can't get out no matter what, so he has to reset his game. And causing that causes his time to reset, so in case that was his best run, now he's got to restart. Another thing you might notice is our music. We have a randomly playing track. It selects different music every time we play. So it's always something different when you play. So I'm going to let Ryan continue until we get to the next obstacle. So now you are introduced to the very first magnetic block. Ryan will be able to turn on his magnetism, and you're able to see the aura of particles around, which will show the amount of room that you could pull a block towards you. So that way we can have distance-based puzzle in a way. So this is a standard magnet, just a metal block. It will come to you no matter what. So Ryan's able to move it and move forward. So like I was just saying about a distance-type puzzle, this block is a little bit higher, and you can't exactly get it. But luckily, his aura is large enough that he'll be able to pull it down and jump on it and be able to progress to the next part. So, like it says here, we wanted to have an easier way to understand negative and positive. So we did a color-based. In our game, blue is positive, red is negative. So in this case, since Ryan is red, negative, and the box is blue, positive, when he turns his magnetism on, it's going to pull towards him uniquely. And he'll be able to jump up and move forward. If he was blue, it would actually pull him, or it would push both objects away from each other, just like a magnet would in real life. So in this case, Ryan notices that if he pulls this block, he's not going to be able to move on to the next part of the level. So what he has to do, he has to make himself positive and push the block forward to fall into the hole and progress to the next part of the level. Same concept again, he has to push the block to move forward. One of the things that we spent a lot of time working on was our tutorials. Because me and Ken had a lot of varying different ideas on how we should teach the player how to play. Ken wanted to be a nicer person, show them step by step. Me, I wanted to just throw them in there and say they can figure it out on their own. So that's why, if you notice, that this puzzle looks very similar to what we had just a moment ago. That was a way to reinforce that the magnetism mechanic, so now Ryan can be able to pull the block, jump up, and progress to the next part of the level. Same concept, he has to push the block away. And Ryan can sprint and move a little faster and get to the end. So when you complete your level for the first time, you have a new high score, you're bombarded with a little bit of information. In the top corner is your score. You see that's your time, and it'll tell you if you have a new high score or not, and you also have fancy fireworks that, thanks to Aaron, this wonderful particle system we're able to put into play to give the player a little bit more feedback. So I'm going to let Ryan go to the next level, and I'm going to see if he's learned enough skill to get to the exit using our mechanic that we've gone over so many times. Like this is a reinforcement type level. So Ryan's just going to try and complete this level and hopefully complete it. So as you can see, Ryan's going to complete the level, and he's going to get a new high score, fireworks, next level. So with this level, we want to introduce two new mechanics at once. We have one, the static block. I know Ken mentioned it before, but for those who maybe don't understand what a static object is, a static object is something that cannot move at all. It's kind of a programming term, sort of. So it doesn't move. But if you are something that does move, it will move you. So Ryan has to jump on this block and use the idea of static and magnetism to propel himself up and to get to the next part of the level. Same thing to reinforce the object, we did it with blue block, positive blocks as well. All right, and for this, we realized while playing that we had a unique idea, that if you could defy gravity by attaching yourself to objects on the ceiling. So this little tidbit is preparing you for the next portion of the level where you're stuck to the ceiling and have to move across. So as you see, Ryan can move across on the ceiling. Now he's being told that he has to watch out for down here. That's our hazard, our lava. So if he touches that, he won't be able to make it. So let's see if Ryan can make it across this gap. And of course, he's a casual, so he can't make it across. So hopefully Ryan's learned his lesson this time, and he can make it across and we move on with the tutorial. And as you can also hear, our awesome soundtrack brought to you by Ryan Campos, which just sounds awesome, which sounds amazing. He's a good tone. Oh, wow! Oh. He really is a casual.
Literally never happens.
Under pressure, pushing down on me.
Yes.
All right, so one thing I know, we discovered a law while playing that we didn't really intend, such as if you have a lot of blocks that are together as one, it increases the amount of polarity, increases the strength. So we decided to have a distance-based puzzle where Ryan can't get up there if he just tried jumping, or jumping and turning on his magnetism. He can't get up there. So we have to stand in this one and propel himself up and shoot himself across to the next part of the level. And once again, new high score. You'll be able to go to the next level, but I'm going to pass it over to All right, go to the main menu and level select. You're able to see that Ryan can now replay levels he's already played. So in case there's a score that he felt like he could beat, like if he thought, man, I want to redo level 3 because I don't want to die by those hazards, he can go back and actually beat his high score this time, hopefully. And as you can see, there are locked levels that you can only use, so you can't go further than you're intending because the levels get progressively harder. And another unique thing you'll see is in the background, as you go to each level select, you're getting a little preview of the level itself. So maybe you're thinking, I can't remember what level 2 was. Was it the one with the hazards or was it the one with the stairs? You can sit at level 2 and realize, oh, that's the one with the stairs. I'm glad they put that in. So now I'm going to hand it over to Aaron, who's going to go over our level editor, one of the amazing tools that help make this game be able for us to progress it so far. And of course the credit screen, which shows all of us and our external help, which without them we really wouldn't be able to make this as cool as it is.
So like Tyler said, I'm gonna show off a bit of our level editor. This is the tool that we developed to really make creating new levels with all our various elements really simple and really easy, and let us create all those levels just really quickly without a lot of effort with code and stuff. So as you can see on the side here, we have all our various game elements that we can put in our level. So if we go back up, you'll notice this brick right here, and that's the basic structure for our level. All those blocks you saw are just what makes up the greater majority of our level. So we can make a very simple block room, just to have an example. And so once we have that, we can start putting more stuff inside of it, like these next blocks here, the simple metallic block. And that's the one that'll always be attracted to your magnetism, as well as the dynamic positive and negative blocks. And so the next block we have now is our exit. Every level needs an exit or it won't work because you can't leave, so we'll just put one at the very end there. Okay, and now we have our static blocks. These are the ones that only move you when you apply your magnetism. So we put a few of those in the air just to show them off. Below that, we have some optional items, which is our background images, keys if you put in a locked door, and tutorial blocks for putting in tutorial text for showing off new stuff. And then at the very bottom, we have our various hazards, just the blocks that sit there, and as well as ones that move up and down and left and right. So we can put in a couple of those just so you have to avoid them. Okay? And so once you do that, you can put in the player start, where you can just put in a code, start, and click right at the beginning of the level. That'll tell the game to put the player there at the beginning of the level. And so we're just about done. All we need to do now is put in our background blocks. If you noticed in the levels, we have a bunch of blocks just sitting behind the player that don't actually affect the game, but just give it some depth and make it really look nice. So this first block here, we can take that and fill in all our empty spaces, and this will make our level just look really nice. So once he finishes this, can just we can select which map number we want, and for the sake of example, we'll just keep it map 0, which is the first one, just to show it off real quick, and then we can just quickly save the map, and it'll create it right where we launched the level editor. So we can bring that up. You can copy over the map right to where we have it in the game content. And once we do that, we can load up the game, and it'll automatically load the map that we just created. So if we start up the game again,
It's the Bluetooth thing that's doing this. I'm curious. There it goes.
you can just go to start. As you can see, we have the level that we just made in the level editor in a matter of minutes.
And that's the level editor.
Yeah. So I'm going to hand it back to Ken, who's going to finish off.
All right, so future development for this game. We definitely have grown very attached to this project over the past 20 weeks, so by no means do we feel like we're done with this. We definitely want to try and continue pursuing, maybe potentially find an artist that can dedicate themselves to the project so that we can actually get our own personal art in there and not have to steal the Android model, and actually have something nice for the players to play with and interact. And potentially put it on Steam Greenlight, which is an indie service that people who want to get their up and coming games, put it out there for other people to potentially buy and play. And then obviously, of course, further refine the game, add more levels in, maybe add in a few more mechanics that the player, challenge the player and give them more options. All right. Now, finally, we have one other aspect to the game that was added in pretty recently. If you want to get the next slide. We have the Mindset headset. This headset right here cost me a pretty penny, but basically what it does is it grabs your brain waves and gives the data back to the computer. So the way this works is we have 3 points on the ear, as well as 1 for the forehead, and you have to make sure each sensor is touching your skin, and it basically grabs the neurons that are firing from your brain as you're thinking. So at the moment, you can't like pick up your arm and the character will pick up his arm, but what it does do is it can grab your concentration and meditation level. If Ryan just double click it. So Ryan's going to open up the brainwave visualizer so we can just do a quick show of how it works, and then we're going to open up the game and show you how we have it implemented in there. You have to hit go to hit manager. Yep.
Cool.
So it is. All right, now let's hope this responds correctly right away.
Might have to get a little closer.
Yeah, maybe always.
Concentrate.
Yeah, this tends to be a little fickle, but usually works pretty consistent like this. Disconnected. No.
Oh, that one.
Yeah, just hit right click, disconnect, and exit out of the brain. It's connected, but it's not picking up my brain waves. I don't know if that says about me.
What a surprise.
I'm just going to quickly clean off the sensors and hopefully we can get a better signal from it.
He's
Oh,
alive.
there it is.
He's alive.
Thank God Ken's brain works.
All right, give it a minute. We're going to wait for the wave quality to reach the top. But right now you can see it's slowly picking up my delta, theta, low alpha, low beta, low gamma, and high gamma brainwaves. What each of those means, I don't really remember, but it's just fancy to say. So, but as you see, it basically grabs all that data and then somehow translates it to how relaxed I am by meditation and how hard I'm concentrating my attention. So obviously you can see this is easy for me because my attention isn't that high. But if Orion exits out of this and enters in the game, we can see how we implemented this in the actual physical gameplay. So if we hit start, so you can see now on the HUD, has been added attention and signal strength. Now the attention is only updated as long as signal strength is 0. Why they put it that way, I don't know. But if it's higher than 0, it just means the signal strength isn't where it needs to be grabbing the data. So now if Ryan activates the magnetism, you can see it's not very big because right now I'm not concentrating too hard, so it's only a 4. But as the attention level gets higher, the aura of the magnetism increases in size as well. So let me see how high I can get this up. All right, signal strength doesn't help me out here. Yeah, I got nothing. And I lost it. All right, well, that's essentially how it works. The mindset is a little bit temperamental at times, so it's not, yeah, Ryan just got to prove that he does know how to do it quickly. But that's the basic implementation of our game. Thank you very much.